The Dutch startup Monumental has introduced an innovative robot for building brick walls. This autonomous machine, equipped with sensors and artificial intelligence, consists of two modules: a material cart and a manipulator capable of laying bricks and applying mortar. The robot can operate in challenging areas, including narrow corners and doorways. The robots perform a comprehensive range of tasks. The material cart autonomously delivers pallets of bricks to the construction site, where the robot then applies mortar to the bricks and lays them according to a specified algorithm. To ensure quality and speed in their operations, the company has used electric and maneuverable autonomous ground vehicles in the production of these robotic machines. The robots are also equipped with computer vision and small cranes, which enhance the accuracy of bricklaying. The devices feature sensitive sensors, computer vision systems, small winches, and the algorithms of Monumental's Atrium software enable them to lay bricks precisely and efficiently. The manipulator robot from ABB, such as the IRB 6700 or IRB 7600 models, represents a high-tech solution for performing complex and precise tasks in various industries. These robots have high payload capacities, allowing them to lift and move heavy loads with maximum precision. They are equipped with advanced control systems and software, ensuring their integration into complex production processes and enabling them to perform tasks with high speed and accuracy. ABB robots can operate in harsh conditions and withstand significant loads, making them ideal for use in construction, engineering, the automotive industry, and other fields. Their flexibility and configuration, and the ability to be equipped with various tools, make them versatile and adaptable for a wide range of tasks, including welding, assembly, material handling, and even 3D printing. The world's fastest bricklaying robot, SAM 100, is setting productivity records. The robot, known as the semi-automated mason SAM 100, was created by the American company Robotics Construction. This specialized machinery can construct brick walls at a rate of 1,500 to 2,000 bricks per hour. This productivity allows it to build a standard house in a couple of days, or approximately 300 houses per year. Despite limited media coverage, SAM 100 has already been actively used on construction sites across the United States. The SAM 100 robot consists of three main components: a conveyor belt, a manipulator, and a mortar pump. It requires the assistance of two people, one to feed bricks onto the belt, and another to monitor its operation and remove excess mortar from the brickwork. Equipped with a 3D model of the building, it is most effective in constructing large structures such as hotels, schools, universities, hospitals, government buildings, or shopping centers. It can even apply company logos to walls using a special sprayer. The accuracy of its work is controlled by a set of sensors and a special laser leveling system. For today, the SAM 100 bricklaying robot has built 8 buildings in the USA, 1 university, 4 schools, and 3 cottages. The vertical rotary parking system is a modern and efficient solution for organizing car parking in limited spaces. This technology significantly increases the number of parking spots on a small area, which is particularly relevant for densely populated cities with high building density. The system operates on the principle of a rotating carousel, where cars are placed on special platforms that move along a vertical axis. When entering the parking lot, the car is placed on the lower platform, after which the system automatically lifts it up, making space for the next vehicle. One of the leading companies that has developed and implemented such systems is the Japanese company Shinmaiwa Industries. These vertical rotary parking systems are known for their high efficiency, safety, and durability, making them an ideal choice for modern cities aiming to optimize space utilization and improve parking infrastructure. A newly developed heavy-lift drone from China successfully delivered 300 kilograms of building materials to an electric power infrastructure construction site at an altitude of 3,000 meters. This drone, equipped with advanced navigation and stabilization systems, is capable of carrying large payloads over significant distances. This marks the first instance of a drone transporting construction materials in such a high-altitude area in the country. The project is located in the mountainous region of Lijiang City, in southwest China's Yunnan province. Due to the challenging terrain, traditional land transportation methods are difficult and can cause damage to the vegetation. The innovative use of a heavy-lift drone for this transportation mission overcomes these obstacles and provides new methods for future construction tasks in high-altitude mountainous areas. Aerolift by Failsafe House Lifting Systems is an innovative steel structure lifting system designed for the safe elevation of buildings for construction or relocation purposes. This system differs from traditional methods using hydraulic jacks and wooden supports, offering a more efficient and less labor-intensive process. Aerolift can lift structures up to 25 feet in a single pass without the need for resetting, significantly increasing project productivity. The system provides clear space beneath the lifted structure, simplifying access and maneuvering for workers and equipment. Each Aerolift tower can support up to 20 tons of load, and the total system load can reach up to 80 tons when using 4 towers, with the possibility of increasing the load capacity by adding additional towers. The new revolutionary 3D printer by Icon is breaking all records by incredibly quickly, and most importantly, affordably printing large 2-story houses. Texas-based company Icon, known for its production of 3D printers, has showcased its new model Phoenix in action. It built a 2-story house in Austin. The new printer is easy to set up and move from place to place, requires fewer operators, and quickly handles large-scale projects. It is half the cost of Vulcan, the previous generation of Icon printers. Phoenix consists of a large, freely moving articulated arm on a rotating base. It was designed to be a more mobile and autonomous device. The previous model Vulcan had fixed columns and crossbeams. According to the company, Phoenix cuts costs by half compared to Vulcan. The system will cost about $25 per square foot for wall systems and $80 per square foot for the foundation and roof. This will save about $25,000 in the construction of a typical American home. Icon's leadership believes that the future of construction and design belongs to artificial intelligence. Therefore, they have released the AI system Vitruvius, which will enable the quick creation of a house design that can be printed on a 3D printer. Write in the comments which of the construction technologies shown in this video did you like the most. If you enjoyed the video, don't forget to subscribe to our channel and leave a like. See you next time.